Welcome, everybody, to episode 35 of the Rule Your Pool podcast. I'm your host, Eric Knight with Orenda, and I am doing this one alone. Couldn't get Jared. Jared's traveling. Joe, also traveling. And I couldn't wait either because I just got off the phone with a customer, and I got to be honest with you, I couldn't wait any longer. I have to record this. I got to get it off my chest while it's fresh on my mind. I have been explaining the same thing over and over and over again with numerous customers, and the reason for that is what we're teaching today is a paradigm shift from what has always been taught. But I promise you, if you listen to this and you do it and you trust in this process, we didn't make any of this up. If you trust it and you actually do it, it will work because physics will be on your side. In today's episode, we are going to explore further on something we've talked about in 2 or 3 previous episodes, and we have multiple blogs about it as well. We're exploring further on how to contain pH rather than trying to control it. Episode 35, let's go.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
Controlling pH, let's just start right here. Controlling pH, not possible. pH is a reactionary chemistry. It is going to move with no matter what you do to the pool. Bathers get in there, they change the pH slightly. Any chemical you add pretty much changes the pH. Every type of chlorine has a different pH impact, and then, of course, the amount of chlorine you put in changes the impact. Of course, acid obviously is meant to control pH, or change it, I should say. But we got to get out of this mindset that pH is something that you can control. You can't. That's not what it's there for. pH is an equilibrium of hydrogen ions. Okay, it's the concentration, negative logarithm of the concentration of hydrogen ions. So every whole number is 10 times greater or less than the numbers around it on the pH of 0 to 14 scale. 7, of course, being perfectly neutral. And we've been taught for so long in this industry that we have to maintain a 7.4 to a 7.6 pH ideally, but 7.2 to 7.8 is acceptable. Why? Why? Now, if you don't have cyanuric acid in your pool, because you're an indoor pool or whatever, got it. Chlorine strength is controlled by the pH. The lower your pH, the stronger the chlorine. Totally valid. But every customer I've talked to, with the exception of one commercial customer, and I mean like dozens and dozens and dozens of companies that I've talked to in the past couple of months about this, they all have cyanuric acid in their pool, at least a little bit of it. That changes the game. If you have cyanuric acid in your water, the pH no longer controls the strength of your chlorine. The free chlorine to cyanuric acid ratio does. So we have to get out of this mindset that I have to have a 7.4 pH or I have to have a 7.5, 7.6 pH. Do you? Do you really? I don't think you do. And I know that sounds a little contrarian, but again, we at Orenda are teaching the LSI first, range chemistry second. Now, I'll be the first to admit, pH is very important. pH does impact just about every other chemistry in the pool. And I'm not going to pretend that I'm a chemist. I'm not. But I have read a whole bunch of information. I've been doing research on this. I've talked to chemists who know a lot more than I do. And if you've got cyanuric acid in your pool, your pH doesn't have to be nearly as low as you might think. Now, it does make a huge difference on your LSI. But there's another way you can do this. What's nice about the Orenda app, if you don't have it, it's a free app. By now, I hope you have it. Otherwise, you're starting this podcast late. Go back. I've probably given shameless plugs for this in all the previous 34 episodes. But use the app and play around with that pH, and you're going to see the major impact it has. But you're also going to find that our app does not make any recommendations on how you balance your water. It just shows you all of your options. We don't tell anybody, oh, you have to have an 8.5. No, we don't. We don't say that you have to do anything with it. We're just showing you what happens if you change different factors like your temperature or your calcium hardness or your TDS or whatever. It shows you all your options. And the point is, there's a lot of different ways to balance your LSI. Having a 7.4 pH and being balanced is great, except it's not going to be a 7.4 pH tomorrow. I want to reiterate this. This episode is about going back in depth over a previous episode that we covered, I believe. Actually, you know what? I'm going to go back on my computer. We're doing this live. It was episode number 29, How to Use Less Acid and Stop Chasing pH. Go back and listen to 29. A lot of what's going to be said today is sort of reiteration of that, but the reason I'm doing another episode on it is not to bore you. It's to really drive home the point that you don't necessarily have to have a 7.4 to 7.6 pH if you have cyanuric acid in your pool. Now, I want to make a disclosure before we go into this. If you are a commercial pool operator and your health code says you can't have over 7.8 pH, got it. You have different parameters. You could still go correct to 7.6 and it'll still be slower to get to 7.8, but I understand that you're not allowed to go to 7.8. And I'm going to give you an alternative on how to reduce that, especially if you have an acid feeder. In fact, I'll do that real quick because I might forget about it otherwise, which is how this goes. And by the way, I don't have a teleprompter in front of me. I have 5 bullet points, and this is not one of them. If you are trying to reduce your pH on a commercial pool, what you really need to know is the volume of your pool and the amount of acid it takes at your desired alkalinity to make a correction from, let's say, 7.81, just over 7.8, or maybe it's 7.9, depending on how good your controller is. Whatever it is, when you hit that threshold where you need to correct the pH, you need to know exactly how much acid it takes at a given alkalinity to drop your pH from that number, let's say it's 7.9, down to about 7.6, maybe 7.5. Whatever your desired is. It's always going to be the same number, provided you have the same amount of alkalinity. The less alkalinity, however, the smaller that number. So maybe instead of trying to operate 80 to 120 alkalinity, like the books say, maybe your commercial pool doesn't need that. Maybe if you're feeding liquid chlorine and it's a summer pool, you could get away with 70 alkalinity or even 60 alkalinity. But I'm going to caution you, do not do that if you don't have enough calcium hardness in your pool and you are not adjusting the amount of acid you're actually feeding. A lot of these feeders are sense and dispense. They're kind of like thermostats. You just feed acid until the pH probe recognizes that the pH went down. Okay, but there's a lot of time in between the time you start feeding acid and the time the pH probe recognizes difference. And oftentimes you overfeed acid, and this tanks the alkalinity, which means you have to put in sodium bicarb, and you're always chasing your tail. It's also very expensive to operate that way, especially when we are in a chlorine and acid shortage. However, if you know the volume you need of acid every single time, that's a very simple thing. Feed that amount of acid as slowly as possible to give the most dilution. Now that's for an acid feeder, of course. So now that we've covered that, by the way, if you are a commercial operator, thank you for listening. If you have questions, email us, info@orendatech, that's orendatech.com, or reach out to us on Facebook or whatever you want, because we're not hard to get a hold of. I'm happy to explain further. Now let's get back to residential pools. I need to go over this again because this is a paradigm shift. And a lot of pool professionals that I've met along the way, they know me now, and I'm going to tell you up front, I don't have years and years of experience being a pool service professional. I never was. I don't pretend to be. What I do have is a lot of experience in the field dealing with problems. Nobody calls Orenda about their good pools. They call us when there's problems, and we like that. But it means that the experience that we do have is in dealing with a lot of the same stuff. And we see it over and over and over and over again. And everybody, for the most part, thinks that their problem is unique. And if it is, I will tell you. Trust me, I will tell you. And the few customers that have ever had that conversation with me, they know which pool was unique. Normally, you're not alone. These problems happen all the time. And the gentleman I was just on the phone with, minutes before opening this up and recording, is having the same problem that I've seen countless times this year and in years past. Can't figure out why this pigmented plaster surface is turning white. He thinks it's scaling. And maybe to some degree, you could define it as scaling, I guess. But looking at the chemistry, that pool has been starved of calcium for the last year and a half. That's not scale. Okay, that is a low LSI violation, and it is bringing hydroxides to the surface. They are carbonating white. It is taking pigment away. You look at little white rings around the aggregate. Textbook, right out of the NPC guidelines, or not guidelines, technical manual, right out of the course material that you can take from the research. If you got white rings around your pebble, you lost calcium hydroxide. Those little white rings, or I guess the areas around pebbles, are known as the interfacial transition zones, known as ITZs. The ITZ is where most calcium hydroxide is concentrated because that's the little pocket between a pebble and the rest of the cement matrix. There's all sorts of really good information on this. The electron microscope shows you up close what it looks like within the cement, but I'm not going to go into that. The point is, if you see white rings around your pebble, you lost calcium hydroxide. This gentleman did. And it wasn't just there. I mean, it was basically on all the cement. The pebbles still looked great, but in some areas, the pebbles were covered with scale. How could that be? I thought it was etching. Well, the pH of calcium hydroxide is 12.6. It gets pulled to the surface. The pH spikes. That pH is high enough to convert bicarbonate alkalinity into carbonate alkalinity. I guess I should say convert bicarbonate ions into carbonate ions. And those carbonate ions then bind to the calcium you just pulled out, and boom, calcium carbonate. And that lands on the pebbles. That's pretty common if you don't dilute your acid and it goes down to the bottom, but it's pretty rare to see that on the walls of a pool. It's more common to see that on the floor, mainly because of the acid. But I digress. I want to talk about why this is happening to so many pools. And a lot of it boils down to this mindset that we have to maintain a pH of 7.4 to 7.6. We're doing our job if we set it every week to this ideal range. And the fact of the matter is, it doesn't work. It doesn't work. In this case, the water for this gentleman was 82 degrees Fahrenheit. So I got my Orenda app open. If you want to follow along, you're welcome to. I understand you're probably listening to this on your phone. If you're driving, don't do this. But if you have the Orenda app, open it up. Let's do this together. So I got 82 degrees on the left side. Okay? I'm going to zero out chlorine, and I'm going to go to the bottom. I'm going to zero out phosphates because they're irrelevant to this example. So I got 0 chlorine. He gets there every week, and it's about at 8.1 to 8.2 pH. Okay, let's just say it's 8.1. Because he gave me, by the way, excellent records. He gave me records from the last 6 or 7 tests, which was awesome. 8.1 pH. Now, what I'm proposing to do is 450 calcium, but that's not where he's at. He's at 200 calcium. So put in 200 calcium on the left, and then put in 90 alkalinity, 50 stabilizer, CYA, and it's a salt pool. It's 3,500. Now, right there, that pool looks balanced. 0.17 in the green. Awesome. That's after a week. How cool is that? Great job. But the problem is, you're not thinking about that 8.1 as a good number. Even though it's physics, it's Henry's law. The pH has got to get up there. CO2 has to equalize with the air above the pool. Again, go back to episode 29. We dive into Henry's law a little more. So what are they doing? Well, they're correcting their pH every week to 7.4. So if you go over to the right side and you correct that number to 7.4, you're not in the green anymore. You're in the red. Minus 0.51. You're etching. And by the way, that's assuming that you are actually only lowering it to 7.4. Now in this example, I've got 20,000 gallons. That's not the size of the actual pool. I'm just doing that so it's more relatable for you, the audience. Because I think we all, especially in the trade, know about what a 20,000 gallon pool looks like. Those of you in markets like South Florida typically don't have them much bigger than that because the yards are not as big. But up in the Northeast, they're more like 30, 35, 40,000 gallons. We're going to do 20,000 gallons for this example. How much acid do you think it really takes to drop down from 8.1 to 7.4? The answer here is 44.13 ounces. I want you to remember that. 44.13 44.13 ounces. In fact, I'm going to write that down right here, 44.13 ounces. Now let's go back. This pool is turning white. It has marks all over it that are consistent with, etching, rebound, scaling, more etching, more rebound, and more scaling. I see it all the time. And I know it sounds counterintuitive, but it makes perfect sense if you understand the LSI. If you are taking LSI balanced water at 8.1 pH, and you are dropping the pH because the book told you need a 7.4 to 7.6, that's going to cause etching again. And the pores of this cement are opening up. Now, if you have a vinyl liner pool, you got a fiberglass pool, the damage can still occur, but you're not going to have this exact chemistry. So maybe this episode isn't quite as much for you. It is relevant because the pH will still naturally rise, but you're not going to have calcium hydroxide in the equation. So I understand that. But we're speaking to the broad audience. So what I proposed to him was, okay, 200, way too low. He gets back to me and he's like, well, nobody's ever told me to raise the calcium. And he's citing, credible is the better word, credible sources like the old APSP handbook and the CPO and, numerous different acronym organizations. And they don't say that you should do what I'm about to tell you. I said, okay, you're in the Northeast. Your pool's guaranteed to freeze, right? He's like, yeah. Okay. You need a minimum of 450. See what that does for you. 450 calcium. Okay, 450. And by the way, I had almost an exact conversation with another gentleman from another pool company in upstate New York, and I said 450 as well. That's not the exact example, but it's very similar. So this conversation is getting blended because I've just had so many of these conversations. So if you're listening to this, I'm not picking on any one of you. This one customer, he knows who he is, but he gave me permission to do this on the podcast. So you're not alone. This is not an indictment on anybody. This is an example that I feel is going to be very valuable for other people, especially if you're a homeowner listening to this and you do winterize your pool. Pay attention. I said, get your calcium up to 450. Now, if you just raise your calcium to 450 on the left side of the app, you're going to notice that that number is no longer in the green. It's actually purple, which means it would be scale forming, 0.52 positive at 8.1 pH. But what if we didn't have to get to 8.1 pH? What if we leveraged Henry's law, which we talked about in episode 29, where we know lowering our carbon and alkalinity on purpose is going to lower the pH ceiling, and maybe we don't actually have to get up to 8.1. So actually, let's drop that to 8.0, and that substantially drops it to 0.42. Still purple, got it, still purple, but we don't need 90 alkalinity to do that. Let's drop our alkalinity because this is a salt pool. And in fact, I don't even know if I said 3,500 salt. That's where you're supposed to be, 3,500 salt. Drop that alkalinity down to 60. And before you lambaste me for breaking the alkalinity barrier, not 80 to 120, this is a salt pool. I get that. The book says 80 to 120. Don't do this if you don't have enough calcium. Don't do this with 200 calcium. You're going to etch every week. But if you have 450 calcium, again, this is in the Northeast. I'm not recommending you do this in Tucson. I'm not recommending you do this in Miami. This is a pool that's going to be winterized. This could be representative of everything pretty much from the Carolinas and Tennessee north. Okay, if your pool gets winterized, this is relevant to you. So I'm at 60 alkalinity, 50 stabilizer, 3,500 TDS, 450 calcium, and an 8.0 pH. Now at an 8.0 pH, I'm at 0.18 in the green. So here's the question. How low should I be dropping that pH? And he's like, well, I still got to get to 7.4. I'm like, no, you don't. On the right side, drop it down to 7.4, and you're going to see it goes red. Now, a way to contain pH is to make sure you don't drop out the floor, meaning go red on the LSI, because containing the pH, if you remember the analogy earlier, and you can see this article on our blog or in the app, just type in pH and you're going to see all the stuff. Containing pH, you want to have the floor of, the analogy I use is an elevator, the floor of the elevator is the LSI. Don't ever go red. The ceiling is Henry's law, and you can adjust the height of that ceiling based on your carbon and alkalinity, but again, I'm kind of spidering off here. don't go down to 7.4. But if you go down to 7.5, you're kind of like right on the line. So I wouldn't even do that. I would go down to 7.6. He's like, down to 7.6? I'm supposed to be from 7.4 to 7.6. I'm like, yeah. But you're also not thinking about the LSI, and you have cyanuric acid in your pool. Why do you need to be low? Well, the chlorine strength. Here again, no, you have cyanuric acid in your pool. The chlorine strength is determined by the pH it's determined by the free chlorine to cyanuric acid ratio, not the pH. If you had no CYA, yeah, the pH matters, of course. But you do. You've got 50 parts per million of stabilizer. Even if you had 15, you still don't have a noticeable difference in the concentration of hypochlorous acid, strength of chlorine. So we got to get out of this mindset that we have to have a 7.4 to 7.6 pH. Only go down to 7.6, see what happens. Get dosage. Now that dose of acid for the same 20,000 gallon pool is 16.81 ounces. Previously, at 200 calcium and 90 alkalinity, it was 44.13 ounces. Now we're at 16. That's less than half. So don't get used to just, I know about how much acid it's going to take. No. Use the app. Measure it. Do not overdose acid. It's the number one bad habit we see. We have previous episodes on bad habits as well. In fact, I'm going to look it up. It is, where are the bad habits? Look at this. Aha. Episode 9 and 10. Both of those. Those are the 6 bad habits. Episodes 9 and 10 of this podcast, you can go back and listen to them. The number one bad habit is acid abuse. Not measuring it, not diluting it, not knowing the volume of your pool so that you add it correctly, not knowing your alkalinity so you get the right dose. Too much acid. This pool, among the other dozens of pools that have called us at Orenda, are having the same problem. Hear me now. If you are having discoloration, loss of pigment, that is not necessarily a plaster failure. In fact, it very rarely is. It's not necessarily bad workmanship of the plaster. It's not. We don't know what it is until we see it. So if you're going to comment to us, send us photos. But usually it's aggressive water that is causing this discoloration. Now there's a difference. Another customer actually sent me one, and it showed clearly big white footprints in the bottom. Okay, water chemistry didn't cause footprints. Okay, that's different. Okay, and water can only react in certain ways. It's not going to directly cause vertical streaking lines in your walls. If it was water chemistry that did it, if anything, it's going to be a moment in time and you're going to start seeing horizontal lines or gradients because the water was doing something relatively uniformly. If it's in one spot on the bottom of the pool, it's probably from pouring acid without diluting it in that spot. These are things that we can go back forensically and find out what really happened. But let's go back to the app. 16.81 ounces. You might think, 20,000 gallon pool, 16.81 ounces, that's a pint. Half a quart. I mean, it just seems so insignificant, but it's not. It's not. I was just in Florida a few weeks ago and went to a cloudy pool, took the chemistry. The pH was very high. The alkaline, it was actually on the third day of a startup, and pH was very high. Alkalinity was, I don't even remember. It didn't stand out. I think it was 90 maybe. But the calcium was a lot lower than they said it, which meant to me that the calcium was in suspension. You're looking at it. That's the cloudiness. I said, okay, well, this pool is 11,000 gallons. Let's lower the pH. And we put in something like 18 ounces of acid. He's like, are you sure, man? Like 18 ounces doesn't seem like nearly enough for this pool. I said, it is. We diluted it in a bucket of water, put it around, brushed, and we left. An hour later, he sent me a picture of this pool, perfectly clear. It felt really good. And I know I'm just speaking to a microphone here. I'm not even recording a video of this because every time I do that, it seems to screw up something else. So I'm not doing that. This is audio only, exclusive to you on the podcast, nothing on YouTube for this episode. Contain pH. Do not try to control it. You can't control it. pH has to rise. So as a quick recap of why. pH, technically it's the concentration of hydrogen ions, but for practical reasons, think of it like this. The amount of carbon dioxide dissolved in your water is going to determine your pH. The more CO2 in your water, the lower your pH. This is why you could use a CO2 injector to lower your pH. The less CO2, the higher your pH. So if you have a infinity pool, like a vanishing edge or a waterfall or a spillway or jets in your spa or anything that agitates the water, the pH is going to go up because you are allowing CO2 to escape more rapidly. Now, Henry's law basically states that any gas dissolved in a liquid is going to equalize with the partial pressure of that same gas above the liquid. The analogy I use is a beer bottle. If you've got a closed beer bottle in your fridge, there's no bubbles in there. But as soon as you open it, those bubbles just start appearing in the middle of the beer, and they start rising to the top. And the reason is, well, number one, you're looking at Henry's law in action. I referenced this in episode 29, but that beer was in equilibrium, or at least the CO2, the CO2 in the beer, the carbonation, was in equilibrium with that pocket of air in the beer bottle. But as soon as you open it, now the beer has to equalize with the room or the outdoors, wherever you're drinking. So the CO2 has to leave. And the bigger that difference, the faster it leaves. But the closer it gets to equilibrium, by a function of a square root, it gets slower and slower and slower. I'm going to say exponentially. I'm not sure if that's mathematically perfect, but it's easier to say. It gets exponentially slower. Okay, it's a function of a square root. So the closer you get to the pH ceiling in your pool, because we know CO2 is determining the pH, and we know CO2 has to equalize with the CO2 above the pool. You're not going to see the bubbles like you do in a beer because you have so much more surface area and you have a lot less carbonation too. But the same physics is happening. You are still losing CO2. It's natural. It's okay. You're not screwing it up. You're not doing anything wrong. Your pH is supposed to rise. Do not get frustrated. I'm getting frustrated because I'm getting so many phone calls about people that don't yet understand this, or maybe they haven't heard it. Shame on us. We're trying to get this message out, but guys, it's okay. The pH is supposed to rise. What's cool about it is you can determine how far it goes. Read that article, read our blog, type in Henry, type in CO2, type in pH, you'll see it. And look at the chart. You're going to see what your pH ceiling is. And just know that you're going to get exponentially slower of a pH rise the closer you get to it. That's a beautiful thing. So you may never get to 8.1. You may never get to 8.0. If you do your job right, and you don't go too low on the pH on the correction, you don't let that number go red on the LSI, you didn't break the floor. You've contained your pH between the LSI floor and Henry's law ceiling. That's all you got to do. And if you maintain this LSI balance where you're in the yellow at the bottom of that containment and you're still green at the top, as long as you maintain that balance year round, you shouldn't have discoloration in your pool. I'm going to repeat that. As long as you contain the pH and you don't go red on the LSI at the bottom or purple at the top, you should not have discoloration in your pool. That is my message to you today. Get out of the mindset that we have to have these 7.4 to 7.6 pH all the time. It's nice. I guess it feels good to have that, but realistically, it's not going to be 7.4 for very long. It's going to change. It's going to rise. You know it's going to rise. And by the way, if you know where the finish line is and you know it gets exponentially slower the closer you get to the finish line, why even go further? Why not just leave it at 7.6? In fact, I got a lot of salt customers, listen to me. I got a lot of customers with saltwater pools. There we go. Good job, Eric. I said it right. I got a lot of customers with saltwater pools that they don't even correct down to 7.6 anymore. They go down to 7.7 or 7.8. And you might think, that's crazy. Why would you do that? You got to get the pH down. No, you don't. They got cyanuric acid in their pool. And guess what? They don't have scale. They don't have calcium flakes. They're running a 60 alkalinity. They're running a pH between 7.7 and 8.1 every week. And guess where it is every week? It's 8.1. exactly like they prepared. It's predictable. Water starts behaving differently. And that is my message to you today. Stop thinking about pH as this requirement of range chemistry. Let it rise. If you think you can control pH, you're sorely mistaken. I'm Eric Knight with Orenda. I hope this is valuable to you. One final note before moving on. The idea of bather load or bather comfort, you don't want pH to be too high because of bather comfort. I don't buy it at all. I've said that in previous episodes. I am a swimmer. I've spent a lot of time in swimming pools. My goggles have come off a lot. And I've never had irritation issues with higher pHs or even lower pHs swimming overseas. I was very fortunate to be able to swim in Europe for a little bit, and they run a lower pH. Never bothered my eyes. Disinfection byproducts do. Combined chlorine, those kind of things, yes. Those things are irritants. But by and large, what we're dealing with in pools with these pH ranges, no. That's not something that's relevant. That's Eric's opinion, but it's a very informed opinion. So be focused on what matters the most. That is proper sanitization, which means a good free chlorine to cyanuric acid ratio, and then your LSI. That way, on both sides of chemistry, your sanitization is taken care of and your water balance is taken care of, and it will go well for you. I'm Eric Knight with Orenda. Thank you so much for your time and for listening to my little tirade here. I hope it is helpful. And I don't know what we're going to talk about in the next episode. In fact, I never would have guessed I would have done this for this one, but it's a pressing topic and I thought it was important to get out there. Thank you for your time.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.